Okay, let's talk about what's called the discriminant. As you can see up here, I have the quadratic formula. And there's something very important about the quadratic formula. It can tell us a lot about the types of solutions that we'll have. Now, underneath the square root, we have this b squared minus 4ac. The b squared minus 4ac is known as the discriminant. Now, what does that tell us about the answers? Well, let's think about it. If you were to take the square, let's say that the number under here, the discriminant, turned out to be something like 25. Then if you took the square root of 25, right, under here, then you would have 5. So basically what you would have is some numbers plus or minus 5. That means you're going to have plus or minus, that means there's two answers. The two answers that you get are representative of the two x-intercepts of your quadratic. Means that if you graph the actual quadratic function, there's going to be two answers. Now, it may open up or open down. You may have something that looks like this, but basically the discriminant being some number greater than 0 tells you that you're going to have two answers. So that's our first conclusion, is that if the discriminant is greater than 0, you're going to have two real solutions. Okay, now let's take a look at if the discriminant was 0, because it could happen to be 0. So if the discriminant was 0, okay, let's just say that this discriminant turned out to be 0. Then in the formula, you'd be taking the square root of 0, which is just 0. So if you had a 0 here, then you plus or minus 0 is still 0. So there's nothing here. And then you just have negative b over 2a. That's only one answer. So this, anytime the discriminant is 0, you have one solution. So let me write that down. If the discriminant is 0, you have one solution. I should say one real solution. And what does this correspond to? Well, if you were to graph the quadratic function, that means that your quadratic function comes down and touches your x-axis at exactly one point. Or it could, do something like that. But the point is that there's only one place where your quadratic function touches. Okay, last case is if the discriminant is a negative number. Now, if this turns out to be a negative number, like let's say you're doing the square root of like negative 9, you're actually going to get an imaginary number. And we can't graph an imaginary number, and therefore there's really, this tells you that if the discriminant is negative, that means less than 0, you're going to have no real solutions, but two complex solutions. And what this corresponds to on a graph is a parabola or quadratic function that does not touch the x-axis. So that's the usefulness of the discriminant. It just tells us kind of about our function and whether or not it hits the x-axis. If it does, how many times.